I'm Lauren. This is Physics 350 Homework 3, problem number 2. We have a circular arc in the xy plane, a linear charge density, and a center of curvature of the origin, and we're going to find the E field at an arbitrary point on the z-axis and show what happens when our curve becomes a complete circle. So here's our r vector, r prime vector, and the d vector, and then the magnitude of d right here. dq is lambda dl, where dl is a d theta. This is how we find the E field right here, and then when we sub in q, we get this. Since we have a constant charge density, we can pull out the lambda. We end up with this. D hat is this right here. It's the d vector over the magnitude of d, and when we substitute it in, we get this right here. And then we have to convert s hat to Cartesian coordinates, and this is how you convert that. And then when we plug that in, we get this right here, and we're integrating from negative to positive alpha of that right there. And then when we integrate, we get this. The y hat component goes away because we have symmetry in the y direction. So that goes to 0, and we are left with that right there at the bottom. So then this looks good because the z component is relatively simple, where the x component depends on the angle as expected, and we have no y component because of symmetry. So then if we have a full circle, we take that same thing that we had before here, but then the x and y hat components are both 0 because symmetry from a full circle. So then we end up with this right here, and we evaluate from 0 to 2 pi because it is a full circle. And then when we do that, we end up with this, and simplifying becomes this. And this also makes sense because we have no x and y components from symmetry of a full ring, and it depends only on the z component.